This is the DJI Mini 3 Pro. Now don't worry, don't click away, this is not a drone video. Drone videos are good though, but this one's not a drone video. It's still a 3D scanning and printing video. What I want to do in this video is basically print a case for it. I'm fed up of folding it up, throwing it in my bag, and then getting it out and thinking to myself, oh dear, I've bent a prop or something like that. So, in this video, I'm going to scan it, I'm going to design in CAD a case for it, then I'm going to print it out and then see how we get on. So, if you want to see all those steps and see how I do it, stick around. So I'm Charlie, welcome back to my channel. The Mini 3 Pro, we're going to scan it, and then we're going to design in CAD a case, and then we're going to print it out. See if I can stop myself bending these props. Now this does actually fold up, so I can fold all these legs in, and then we're going to scan it for the little case. Now it's going to be a relatively easy scan. I'd say I'm probably going to scan it that way, and then flip it over and scan it that way, and then join it in the software. First of all, though, looking at it, I'm probably going to have to put a little bit of scanning spray on the lens protector. The rest of it should probably scan well. So I'll get some scanning spray on there, get it on the turntable with some markers, and then we'll see how we get on. Okay, that should be enough then, I think. I've got my little shields, as I like to call them, around the outside. So then when the scanner's looking down on the drone, it's going to see them at the back. But I find as well, because I want to get a top-down view as well, it's nice to have these little domes in there as well, so at least I've got something which is perpendicular to the scanner when it's on the top. I'm going to do a global marker, and then I'm going to do cross lines. Now this is only a space-saving video, this is really, just to get the general overall sizes of this. So, a quick cross lines, not caring too much about the detail, that'd be good enough. But I can't do that, can I? Got to shout this thing off. I'm going to be doing it with the Sermoon S1. Let's start off with a global marker scan. I'm going to come down to 0.3 for the scanning cross lines. Now, with just a couple of revolutions on there for the space climbing video, that'd be perfect. That'd be all we need, because we've got the extremities here, we've got how high it is. If we come from the top and have a look down, we can have a look at what's there. So when we're designing it in CAD, that'll work out a treat, that will. That's all we need. However, we don't just make do on this channel, we scan things properly. So, I'm going to put it onto single line, and I'm going to get all those gaps. I'll spin around it quickly, and then we'll see how we get on. Look at that, how that's filled that in now. All nice and blue, so we should be good to go. Flip it upside down and then start another one. Okay, we'll call that finished then. Let's process the scan. Use them both together. 0.3. There's scan 1, and there's scan 2. Now, as I've said before, I like to leave the bases on until I've fused, because I think it makes a better cut. So now I'm going to cut the bottom of this off. We've got to think about where we're going to cut. I'm going to do a nice clean cut, and I'm going to do it halfway up that gimbal protector. Now scan number 2, where I'm going to cut on this now. I'm going to take away a nice little chunk as well. What I don't want is these little jagged edges here appearing in the join. So, as per the other one then, let's go to about there. Chop that off. Processing, alignment. Let's automatically align those. Let's mesh it to 0.5. The reason I've gone to 0.5 is because I'm going to be using this in Fusion soon. And Fusion doesn't like handling big meshes. Now this is a perfect example about how chopping the mesh cleanly before you align it is a good thing. For instance, let's just look at the bottom here. If I get rid of the one scan, you can see where that clean edge is at the bottom. Let's just zoom in a little bit more. You can see where that clean edge is at the bottom. Now if I put the other one in, can't see the join, can you? And that's because this scan is a good scan and this scan is a good scan to the edge. So therefore you put them both together and you can't see the join. And it's happened at the top as well. So there's the joined. That's where I've chopped it off. So that's a good scan. And add that in and you can't tell the difference. However, here, across the propellers there, look, you can see where the join is like a seam line. And that's because that's a good scan. But that's got a crappy edge. See, those edges are a bit crappy. Okay, so let's try a bit of an experiment then. So if I turn it round to the side like this, and make sure I've got penetrate selection on, and then select a little bit of that there. Okay, chop that off. Accept it. When I bring that one in there, you're not going to get such much of a bad line, am you? Obviously it's in here as well, but it's just things to bear in mind really. Get rid of the ragged edges if you can. Okay, so let's mesh that then. Now as you can see, now I've meshed it, the edges, which was a bit ragged, it's fixed them a little bit. Still slightly evident there, but it's done a good job of getting that back. This across the front now, you can't see where that was. Okay, let's send this out to Mesh Mixer. That's a good scan, that, isn't it? Look at it, having a look at the join across the bottom. That gimbal guard there was where we joined it. You can't see the join. You can't see the join at the top because we had a good cut off there. Having a look at the join across this, we minimised the problems there by chopping it off. And it's aligned well, look, because these are in a nice line. I take you back a little bit. I thought that was going to cause us more trouble than it was. But it hasn't. You can just about see, you can just about make it out knowing it's there, but it's done that well. But I think you'll find now that that single line laser has done a great job of getting into some of these gaps. Okay, so that's going to be a nice scan then for the CAD. Okay, so that's it then. Stage 1 done, scanning. The Sermoon S1's done a great job of that, hasn't it? We went a little bit overboard, I think, but we don't do things by half measures on this channel. Next stage then is going to be the CAD Design. Okay, so here we are then within Fusion 360, and as you can see, the mesh is sitting there, albeit cockeyed at the moment. And it's sitting at that angle because at the time of making this video, you could not align the mesh within the Creality software. You had to do it within another software, and I like to do it within Fusion. For a video as simple as this is going to be, to make a box for this, the scan doesn't need to be really accurately aligned. However, I don't do things by half on this channel, so I did make a real meal about aligning this. I ain't going to go into it now because it's a bit long-winded, but for those of you who are a little bit interested, basically what I did was I created a plane on the back of the item there. Then I created a mesh section sketch. If I just hide the body now, you'll see what it cut through. So once I've created this mesh section sketch, I drew a few lines on it, defining those circles on the end there, found the middle point, and then aligned it basically to the coordinate system as per this now. And as you can see, just basically align those lines with the base and open it so it was upright as well. So if I now go to the front view and come right in, I then moved it up. So basically the bottom plane is perfectly in line there with the edge of that. And the top view is the origin there. Is basically in line with the back plane as well. So for those who are interested in how I did that, that's how I did it. But it really did not need to be that accurate at all. You could have basically just got it in there, eyeballed it, moved it a bit this way, turned it around, moved it a bit that way. You know what I mean? It's as accurate as you need it to be. The first thing I did next, I created a sketch on the bottom plane, and I basically drew around the edge of the contour here, and then I mirrored it over to the left so I wouldn't have to draw it twice. I just eyeballed some dimensions to start with, just so I could get started. These are the dimensions I ended up with because this actually is completed. Once I'd done that sketch then, I extruded it up to give me a complete box. Now, why is there just a little bit popping out the top here, you ask? That's because... So why is there just a little bit popping out the top here, you ask? Well, obviously, when I first did this, I would have extruded this far higher than that. But I've since shrunk it down, because as you'll see as we go further on, it didn't need to be that high. So after the extrusion then, I basically put a couple of fillets around the outside to make it look a bit more aesthetically pleasing. And then I put a chamfer on the bottom edge. Now the reason I like a chamfer on the bottom edge there is because I think it helps the print. When you're printing off the bed, a chamfer there prints better than a fillet. And I think it looks okay as well. And I'm just going to make sure that I match that on the top. But for around the edge here, I thought a fillet looked the best. Then I hollowed it out, leaving a wall thickness of about 3mm, I think it was. So if I wanted to just double check the wall thickness with this feature, just click on that face, click around to that face, and it will measure 3mm. And you can see it over here as well. So yeah, 3mm wall thickness. And because those chamfers as well were put in pre-hollowing out, it puts a nice little fillet on the inside of there. And if I just hide the scan for a second, it puts a nice little chamfer on the inside of there as well, which matches that. So at this point then, we can see whether we think we've got the box at the right dimensions. So if I go perfectly on the top and make sure that I'm in orthographic view there, which basically means you see straight down, and zoom in with the mouse rather than use a space wheel, I can see that I'm going to miss everything there and around here as well. And make sure that I come into orthographic view there now, and I can see down the bottom. But as I say, when I first did this, this was a lot bigger, and then I've just basically gone backwards and forwards until I think to myself that that's about what I need. At this point as well, I thought I'd create myself a couple of analysis views with some sections in. That's my first section I got to see whether anything was failing, to see whether I think it'd fit in and stuff. And as I say, that'll become evident in a minute why that's that high. And I got another one here, I think it was, that's just chopping the top off, which will become a little bit more evident in a while. And that one's chopping it the other way around, so I can just see what's available there. So I created this sketch and created this little profile here which stuck out. That then, using the sweep command, I swept all the way around the outside. So if I turn off the analysis views, you'll see that it comes all the way around the outside. And it's got that 45-degree angle there. So when it printed, that wouldn't be an overhang, so that'd print nicely coming through there. That feature will also become evident shortly why I did that. Then I created another component, and I wanted to build myself a lid. So I created a sketch right on top of the lid, projected the feature that was there already. Let's edit this sketch so you can see. Projected that feature that was there already, then drew myself a line using the offset command up here to be 0.25mm in. And that was to produce my lid to give myself some clearance. I then extruded that downwards. So if I look closely now, you can see that I've basically got a lid which is level with the top of there, but goes downwards 15 millimeters, because I extruded it down 15 millimeters with a 0.25 millimeter offset all the way around. So let's get to one of my analysis views then, and you'll see exactly what's happened there with that. So as you can see, there's the lid coming downwards with the gap. And there's it is the other way. Then I drew me another sketch where I basically followed the contour of the outside of it, so then I could extrude upwards to make the top of the lid. So if I turn this sketching off now, then just to hide a few things, put the analysis view back as it is, I've now got a lid which fits perfectly on there. I've now got a lid that sits perfectly on there now, like a bung going into a hole with 0.25 millimeters gap. And as you can see here, I need to get rid of some of this here now, because I wouldn't be able to get the drone inside if I didn't hollow it out. So leading on to the next bit was hollowing out the inside, putting a couple of chamfers on the outside there at the top. Then I put a chamfer on the inside here at the top. Now you can see then I've got my lid in there. I'm not fouling on the drone there. I'm not fouling on it this side. The top now misses there. So that's how I came to the height of the initial case. As I say, when I first made it, it was probably up here somewhere, and I just reduced it and reduced it and reduced it until I got myself a nice decent lid size, and it didn't touch the top of the drone because I wanted it to be as small as possible. Now came my dilemma. How on earth do I make this so it fastens on? I thought about all sorts of things. I thought about putting some ridges in here and some lumps the other side, so it was sort of a press fit. So I thought, how am I going to do it? And I decided I was going to do it with magnets. I'm going to have magnets holding this lid on. Normally you'd probably think about having the magnet round that way, but I thought, no, I'm going to have them vertically. 2 magnets, one on the lid, one in the case, vertically to snap together. So I use these magnets, and as you can see, they're little magnets. I got them from Amazon. They are 10 millimeters diameter and 3 millimeters thick. They're only pence, these are. 2 of these together, it'll hold any lid on. So the way I did that was, first of all, I created a sketch on the front of the lid, and then I extruded. I went 3 millimeters that way just to sink the magnet in, and 3.25 millimeters that way, because obviously the sketch is on the side face there. So the first 0.25 millimeters of the extrusion to the right, as I'm looking at it now, will be the gap, and then obviously 3 millimeters into the part. Okay, so then I did another sketch and another hole over at the back, and another sketch, another hole on the side here, and then obviously just to finish it off, another sketch and a hole there. So looking at these other views now, then you can see exactly how they're going to work. Magnet in there with the gap, and in there, and those are the other 2 to the side. And to finish off, I just put an extra chamfer there just to make sure that there was definitely no fouling on the way in there, and a chamfer as well on the inside of the lid here, just there, just to help it feed in. I tell you what would be really nice on this, but I don't know how to do it, and if anybody knows, let me know in the comments. With this section analysis view here, it'd be nice if I could just basically say to the section analysis, only cut the box, but leave the scan, and then I can see how the scan's going to be inside and the box on the outside, but I don't know how to do it. So as you can see, when you actually look at the section analysis, you can move this backwards and forwards just to show different parts of it which is good. I mean, I obviously stopped it there right in the middle of the hole so I could see how the holes were forming as I was designing. But if you wanted to just see it from the back edge or all the way to the front edge to see how things were going to fit, then you could do. And then you could obviously change the angles as well, so you can clip it around that angle and then go inwards. And you can have it at more than one angle as well, so I could bring it around that angle. And obviously in and out. It's really good, really clever. But it'd be nice if I could say, only section one thing, but I don't know how to do that. So the next thing to do then on here is to print it out. Now, I don't want to print all of it out now because that's going to be a waste of filament to start with. I want to see whether this lid is going to work, whether that's going to fit. So what I'm going to do to start with then, I'm going to print out the lid and I'm going to print out the case, but just from about there upwards. So I'm going to do this then. I can't use the print facility to send two things because it'll send them together. So what I'm going to do is I'm going to go to making sure that that is set to export rather than print utility. I'm selecting the lid. I'm going to go to export, and this is going to be called lid. That's going to be dropped on the desktop. Then I'm going to go to make again, come down to the case, still on export, and this is going to be called case, and drop that on the desktop as well. Then I'm going to open up Bamboo Studio, preparing myself a new project. I'm going to bring in off the desktop the case and the lid. There they are. I'm obviously going to print that the other way around, so I'll flip that over onto its roof. Now this one, I'm going to position it, grab the blue handle there, which is obviously the Z, bring it down below the work surface. That means I'll be saving all of this, because obviously because that's below the bed, that won't print. So now I can print that off now to see whether that is going to work. First of all, I can pass my drone through there to see whether that's going to fit. That'll give me one idea about whether I've got my dimensions right, and obviously see whether this will fit onto there and whether all the edges will marry up. It doesn't need to be a friction fit when it holds itself on, because that's what the magnets are for, but it needs to be enough so it's not too sloppy, but there needs to be enough clearance so it's not too tight. So I'll give it a go at 0.25mm and see how we go. Okay, so both prints have been done. Got the lid, I've got a little bit of the top of the case, just so I can see whether the mating faces are going to work or not. They do fit together. You've got to be quite accurate with it though to get them in. If you put it in slightly out of square, it won't go in properly. You've got to actually put it quite accurate to get it in. But it sits nicely once it's in there. So I'm pretty happy with that. So because I'm happy the way that they fit, I went ahead and I printed a full base, which is here. The drone, let's see if the drone fits in okay. Yeah, the drone goes in there quite nicely. And if you look at it from the angle, you can see that it does. Whilst I was printing the base off, and I was going to print the lid off, I decided I wanted a little bit more clearance around the outside of the edge. So I changed that 0.25mm clearance to 0.75mm. Because what I wanted to do, I wanted this to be able to be put on whatever angle you was at, it would drop in. So if I put it in like that, it would drop in. See? It would just drop in. However, the problem is, it's too sloppy. I thought because there was 4 magnets in there, the magnets would hold it perfectly in the middle, so the edges would be perfectly square, but they're not. I've obviously got 2 magnets to one side, which are stronger than 2 to the other side, so it basically pulls it over to one side. So I printed off another one. This one, I printed at the original 0.25mm. Press the magnets into the edges, as you can see there. And that one now fits as per the test piece. It fits really nice. The problem with this now though is if you put it at an angle like that, it won't actually just snap down. You've got to have it quite accurate to get it in. But I think I can live with it. It's strong enough to stop that coming out. So I think it's done the job. I'm going to call that done. This can now go away in the bag, use it at the end of the day, and hopefully when I go to fly the next day, I ain't going to have a bent prop. Hopefully when I go to fly the next day, I'm not going to have a bent prop. That'll do for today's project. I am going to do some more, but until the next time, thanks for watching.